Hello and welcome to lesson 6.2 on composite functions. Now, we already know a good bit about playing with functions. Earlier in this semester, we learned how to plug into functions. Earlier this semester, we learned how to use function notation. Just last lesson, we learned about domain and range and when something's a function or not. So today we're going to take our kind of next step in using functions by learning about composite functions. Now we already know how to plug something into a function. Like if I were to give you um, f of x equals some function, blah, 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 I don't know, make one up, x squared plus 2x plus 7. I could ask all of you out there to find me f of, pick your favorite number, 4. And everybody could do that, right? We could all do that. We know how to plug in a number. That's great. Now, the power with functions, or the important thing with functions, is that the reason we like function notation is it gives me the ability to plug in more than just numbers. It gives me the ability to plug in more than just a little lonely variable. It gives me the ability to plug other stuff as huge as other functions into a function. And that's what function composition is. It's when we take one function and plug it into another. Okay? So for instance, this is often written kind of in this way. So if I have the function f and I would like to plug the function g of x into it, this is what we end up writing. So you see the outside function's f. What is plugged in is this whole function g of x. And that function is going to have an x in there. Okay? And so I can kind of nest or stack inside each other functions. Now, the actual fancy function notation way of writing this is to write a little O or a little circle between the F and G, and we could write it this way. So this is kind of the fancy way of writing it. And the way we read this is earlier, if we just had something like f of x, we read that f of x. The way we read this is f of g of x, or f of g of x. Now, all the questions, I think we're going to write them in this way, but what we're going to do is rewrite them back to the green way so we could see, okay, which function is plugging in. Notice the order is the same. The f comes first, then the g. Okay, I think I can handle this. Okay, so we need to figure out how to simplify or and even evaluate once we start plugging numbers into these compositions, how to handle these composite functions. Okay. Now, we'll say we're not going to do anything difficult in here, but when you get into Math 111, we just learned about domain and range. It'll be very important to pay attention to the domain and ranges of these functions, because if f can only take certain values in its domain, then that means the things coming out of g in its range will have to kind of match, or will have to be smaller than or less than the domain of f, so that you don't try to plug in things that will make our function undefined. For instance, if f was a square root of just a square root function, I can't plug negative numbers in there at this point in math. Later you'll learn how to deal with stuff, but for now I can't plug negative in. So if g of x goes into the negatives, I may have to, like, say this could be negative infinity to positive infinity. I may have to be careful plugging g of x into f of x. Don't worry about that in our lesson, though. We're not going to go that deeply with functions. Everything I'm going to give you is going to be pretty simple to handle. Or at least I won't make you plug in numbers that go outside of domains and ranges. We're just learning to do the composition today. Later we'll have to be more concerned with that, okay? Alright, so why would I want to do this? This is very useful in a lot of things. A lot of modeling and stuff may have functions to model certain things, and then that output from that function may be plugged into another function. For instance, if you have a theme park and you've decided you have these snack stands, and you could either have them equipped to sell ice cream or to sell hot cocoa. And the projected number of sales would be based off of probably temperature. When it's cold outside, hot cocoa sells more. When it's warm outside, ice cream sells better, sells a lot more. And so what you may do is you may have a function that estimates the temperature. And so you would need the temperature to plug into your function to estimate how much ice cream and hot chocolate to sell. And so it would be easier just to plug them into each other and have um, one whole function instead of two separate functions that you have to plug into twice. So, but let's jump into an example here. So here I've defined two functions. I've defined the function f of x, and I've defined the function g of x. Okay? And what we're going to do is we're going to discover some things by asking you to find, let's just see if we can find oh yeah, it's going to write it this way, f of g of x. And then later we'll ask you to find the other way around, g of f of x. Okay, so we'll start with this one. And the first thing I would like to do is write it out of this, take it out of this fancy notation and write it more how I like to see it, where I see that, oh, I have function f and I'm plugging something in it. What am I plugging in there? I'm plugging in the function g of x. So how am I going to do this? How am I going to write this out and simplify it and get some sort of expression or some sort of final function? Well, that's pretty simple. What function is on the outside? It's f. So let's use our good technique that we've learned, our proper technique for plugging into functions, and let's grab the function f. It is simply 2x plus 3. And so remember, our good technique is to go 2 blank, I'm going to probably need a bigger blank than usual, plus 3. Anywhere there are x's in the function f, I leave a blank. I rewrite the function with a blank. That's what we've been doing all semester long. Now, what is going to plug in to this function? G of x. Now, it may take one extra step to be annoying. This is not proper at all to write the function in here like this. We're going to plug g of x in there. Now, I don't want to put g of x, so let's actually put what g of x is equal to. What is g of x? X squared plus 2. So in this spot, I am plugging in x squared plus 2. Okay, so let's see what I have here. I have the function in green that's f of x, and I have plugged into it g of x in white. Okay, I think we can handle this then. I think we have enough skill. And so I would like to simplify this. And so simplifying, let's see, I can distribute the 2 and then combine any like terms. So that would be 2x squared plus 4. And don't forget the lonely plus 3. So this can simplify in a few steps. Now I need to combine like terms. 4 plus 3 is a like term. And so I get 2x squared plus 7. Okay, that's not difficult at all. That took a little bit of algebra. The hardest part is knowing, okay, the outside function's f. Let's write f down with a blank. The inside function is g of x. Let's take g of x and plug it in there. And so from this, I should be able to ask you questions like, okay, well, now that you've found f of g, can you plug in a number? Let's just plug in 5. And so instead of doing all this work again, I have found that f of g is this right here. And so I can plug straight into that if I wanted to know what f of g of any number is, 5. And so remember, using my good techniques, I rewrite it with a blank for the x, 2 blank squared plus 7, 2 blank squared plus 7. And what are we plugging in there? A 5. And so I just do a little bit of arithmetic and I can find this value. 5 squared is 25. So I have that when I square the 5 squared. Let's see, 2 times 25 is 50 and plus 7, so that's 57. All right, so it's not difficult to plug into these either. It's just like plugging into a normal function. All right, I'm going to, let's shrink this down to give us more space for the other example here. Oop, I lost a little eyebrow there, but that's okay. We'll just delete that. All right, so let's work this other one. Actually, I'd rather pull it up to have some more space. All right, so working this one. The outside function, or let's rewrite it this way. The first function is g, so this is g of f of x. So doing it the other way, the outside function is g. This one may take a little more work. So let's see. G of x is x squared plus 2, blank squared plus 2. So blank squared plus 2. And then what am I plugging in to g of x? I'm plugging in f of x. So right here in my blank, I need f of x, which is 2x plus 3. Now I need to simplify this, and now I have this function composite. But look at what I have here. I have a whole polynomial squared. Thank goodness for last chapter where we know how to do that. I may take the time to write it out. So that's 2x plus 3 times 2x plus 3. Remember, that is the best technique to handle a squared polynomials, to write it out twice, so you will remember to distribute or super distribute everything. And don't forget your plus 2. And so let's see if we can handle this bit of arithmetic here, or simplify in algebra. So that would be 4x squared. I don't need this parenthesis out front anymore. Get rid of it. Plus 6x plus 6x plus 9. And a lot of people, when they do this style, forget the plus 2 because they're so excited they did all this work. So don't forget the lonely little plus 2. And then we'll just need to combine like terms. 4x squared. Notice I have a plus 6x and a plus 6x. That's plus 12x. And then I have a 9 plus 2. So that's a plus 11. So there. We have found this composite function. And we could do the same thing. We could do g of f. And let's do the same number. I want to talk about something and kind of discover something here with these function compositions. First off, just at first glance, does it look like order matters in function composition? If I ask you for f of g and you do g of f, are we going to get the same answer? Up here I got 2x squared plus 7. Down here I get 4x squared plus 12x plus 11. Oh my goodness, those are definitely differently looking. Maybe they'll give the same answer. I don't know. So let's try the same number to see. If I could in fact get this. Let's see. So what is g of f? It is 4 blank squared plus 12 blank plus 11. So 4 blank squared plus 12 blank plus 11. And hopefully you're intelligent enough to see that, oh my, this is not going to equal 57. Because when I put a 5 in here and a 5 in there, because that's what we're trying to plug in, we're definitely not going to get 57. So let's see. Let's just do the 5 squared is 25. We can go ahead and handle 5 times 12, which is 60, plus 11. 4 times 25 is 100. So 100 plus 60 is 160, plus 11 is 171. Okay. Well, is 171 equal to 57? Absolutely not. So that kind of shows us our one thing, that order of composition matters. So if I have f of g or g of f, or sorry, h of g of h, or sorry, what letters do I have here? F of g or g of f, those are drastically different functions in the end. So if I ask you to compose them, don't be lazy with the order. Order does matter. You will get different answers. Okay? All right. And so being able to put a function inside a function and simplify, and being able to plug a number into that simplified thing is all that I'm asking you to do in this section. Okay? Well, that's all I have for you today. See you next time.